In previous lecture we saw first three steps constructing a root locus. First step was little easy to understand, that it is actually symmetric about real axes. And then we also characterized where do the root locus, where does the root locus start at k equals to 0 and ends at k goes to, what happens when k goes to infinity, and then we concluded that they starts at poles and ends up at 0. And then what if more number of poles than 0, the remaining poles goes to what we define as zeros at infinity. So we also easily computed to see if what area of real lines are on root locus. So that was just a small test based on how many poles and 0 lies on right of that particular region on real line. So continuing on that, the further next step here is how do root locus branches go to infinity. For example, in the motivating example, we saw that we had this guy. I had a pole at 0, at minus a, they meet here, they goes at infinity. So what decide this? Why does they go something like this, right? Why they don't do something like this or this? They just, instead of going on right line, they can go for lazy path, and can they go to infinity in this way? They want, or there is something that decides that, right? So the statement says that n minus m roots. So we are only interested now on roots or the poles which goes to infinity. So n minus roots that proceed to infinity, they do so along asymptotics with this. So they are asymptotes with the angles. Okay, so I will show you shortly how this is computed, right? How this value is computed. So let us consider a test point at infinity. So this is my test point. Okay, and let's do a little thing. Let's erase this. Okay, I will just erase it. So let us consider a test point at infinity. And let's say I have over here a sigma and j omega plane, and this is my infinity here, right? So there is a guy, say S naught at infinity. I am taking test point as S naught. This is S naught. Okay, then there would, open pole and zeros there, whatever. So I just say there are two poles, right? So I just look at how the angle approaches goes here, then keep going, and then it reach till this guy. Okay, and this guy is still very far, so I just do something, right? So here, then again they meet here, these guys meet here. Okay, so this test point which is at infinity, so what are these angles, right? This angle, so those are the angle made by line joining test point which is at infinity. So what are the angles, right? So this is the line made by test point and open loop poles in 0. They are almost equal to each other, right? So if I look at 2 points very far away, they will seem just very close to each other, right? So this is like infinity, and let's say both of them kind of make the same angle phi a. So how many number of angles are? So there should be n minus m number of angles, right? So that should be difference between number of poles and number of zeros. So the net angle made by all open loop poles and zeros to test point should just be, well, n minus 2 times of that, right? So net angle made by all the open loop poles and 0 to the test point just be, well, this guy n minus m with negative sign, because we are dealing with poles times phi a, right? So these are two things here, right? So this is phi a, this is phi a, 2 times of that, right? So I think we are only interested in n minus m guy. So what should be these angles? So all these angles, they should satisfy the angle criteria. What is the contribution at infinity of this guy? So the total angle contribution at S naught must satisfy the angle criteria. What is angle criteria? It says that angle should be odd multiple of 180 degree. What is this guy? N minus a, n minus m phi a is this guy. That means I can just compute phi a, that should be equals to plus minus 2q plus 180 degree. Okay, so this angle now computed as just this term. This is not surprising, right? So let's do the same example again. So let's take starts from 0 minus a. Now that 2 guys goes to infinity from some point. So what is this phi a? Phi a is, say, there is 180 degree divided by 2, that is plus minus, this is plus minus 90 degree. So this guy will go like this, so this is positive 90 degree, this guy will go like this, so this is negative 90 degree. So these proceed to infinity. Do so all along asymptotes with an angle which are depending on number of m and n, right? If there are more than these guys, the angle will change accordingly. If there is only one, say for example I take 1 by s plus 1, so this is g, right? This is g. So I can draw the root locus. It will be somewhere here minus 1. Okay, so this guy will goes to infinity. The angle should be either minus 180 plus 180 degree, or it can be minus 180 degree. Both are same, right? Either this minus or positive 180 degree. Okay. Okay, now so these asymptote, well, we have somewhere, they have some starting point, right? From on complex plane. So the centroid, or a point of intersection of asymptotes with real axis, can be computed in this way. So I guess all the real part of pole minus sum of all the real part of 0 divided by number of pole minus number of 0. So this is n, this is n minus m. So where does this come from? So okay, what was the open loop transfer function? That is kgh. Okay, so what I had was a set of zeros as in numerator, a set of poles in denominator where m is less than n. Now I just do some high school algebra just to say, well, this I can write in decreasing power. Okay. m minus 1 with the coefficient being the sum of all these guys until I reach the last point s to the power 0. Well, yeah, it is the sum of all these guys and this is the product of all these guys. So similarly, denominator I start from sn minus 1 and this is the product of all these guys and this is sum of all these guys. Okay, so I am just dividing one guy with the other guy. So I am just dividing this one guy with the another guy. So how does the characteristic equation look like? So the character equation I am interested in is 1 plus g kg h equals to 0. So what I am aiming to solve, right? Okay, so 1 plus k look like I just add 1 here. I just add 1 here and go here, right? And I just divided them. So how will it will be like this. I'm just dividing this with this. So I'm having n minus m. It will have a power of n minus m minus 1 and so on. So what will be the coefficient? Coefficient of n minus m minus 1 is that just the coefficient is the sum of all the pole minus the sum of all the 0, and then you just have this series. Okay, and now where is I'm looking again. So my axis s is here. Okay, so this is my test point is here at infinity, s naught. So this is my infinity, and if the test point is very far, means I am looking at very large value of s. So I can just do my analysis just that these two terms. Then I can contribute the remaining terms would be very small. Then really looking at really large value of s. Okay. So my character equation can equivalently written as 1 plus g k h. Okay. So this guy is 1 plus k s n minus 1 s n minus 1 minus n is equals to 0. So coefficient is the nature of poles and nature of zeros. Now okay, let's do something else now, right? So let me start with a transfer function which has n minus m. I'm just doing something else where I'm just taking a system where I'm having a transfer function which has repeated root at sigma a. It has no zeros. So how will that look like? Well, kgs, like just you can assume hs is equals to 0 or add hs doesn't really matter. So kgs would be something like k by s plus sigma a n minus m. Okay, so now again the characteristic equation, I just add 1 plus to this equation. So this is my characteristic equation. So how will this root looks like? So well, the root has no zeros and n minus m poles. Okay, so this root locus of this open loop system here with hs is equals to 1 of this open loop function where hs is equals to 1, they starts at say some point sigma a. and all of them goes to infinity, n minus m branches. Okay, so that will tell us, right? So what happened when, so this sigma a, then there is n of these root n minus m branches will go to infinity. Now let's just expand this a little bit, right? So this is s power s n minus m s n minus m minus 1. Okay, so we do the binomial expansion, and in the denominator I have power of s n minus 1, and then now I'm just summing up this way, right? So if I just substitute this formula directly to summation of all the poles, how my poles are there, how many poles are there, n minus m of the poles are there at sigma a. So therefore the second term would simply be sigma a n minus m. So these are the sum of all the values of s n minus m minus 1 and so on. So again, for a large value of s, I just stop here and say, well, this is a good approximation of at the large value. Therefore a straight line roots, the straight line root locus branches of transfer function in the equations are asymptote of transfer function with centroid. Okay, so everybody starts, we just started here, okay, we just started, then we just divided it, so I get this value p summation of poles minus summation of zeros. Then in this another equation, for that I am having n minus m sigma a. Okay, so I am just equating them. Okay, so in straight line root locus branches of transform function which has sigma a poles n minus m poles at sigma a, then the negative side, they are asymptote of transfer function with centroid sigma a. All of the asymptotes start at sigma a. So what is the relationship of this here? We start over there, from comparing those two equation, I will get this equation. Okay, so if I just equate this, I just get something like this, n minus m sigma a, and this guy sigma in a general way, because what I showed earlier, then we were even looking at the angles. Okay, so if I start at some test point s naught, and if I am having two poles, like suppose if I am having two poles, one is p1, one is p2, another is p2, p1. So if I look from very far, it might just look, it must just seems like all these two poles are at same location if I am just watching it from infinity, because angle contributions are almost the same. So I can take this analogy and I can just say, I can equivalently view this as where I have two poles at sigma a, means p1 and p2, from the far point is visible to be one point placed at sigma a. So sigma a is left half plane from infinity it looks. So this guy p1 p2 will be exactly look like this, means they are at same point if I am watching it from infinity. Okay, actually close to each other, and therefore the centroid point of asymptote can be calculated this way. Okay, just by equating this expression here with this guy, so I know infinity. Okay, so what is this guy? So centroid point is the sum of all the values of real part of poles minus real part of 0 divided by n minus m. Okay, and this is how I calculate centroid point. So let's see how it's look like, in terms of small example. So take gs is equals to k by s square plus 4. So there are three poles of the system. Okay, again hs is equals to assumed to be 1. So wherever gs is given can be assumed as hs is equals to 1, and if we always know how to transfer or transform non-unity feedback system to unity feedback system. So we can do the same analysis. So coming back to this, so given transfer function, we are having 3 poles, so we will have 3 branches of root locus. Okay, and so these 3 branches, let me just approximately draw something here, right? Okay, so I have one pole at 0, I have another pole set s square plus 4 is equals to 0, so s is equals to plus minus j2, so one is here, one is here. Okay, so when k equals to 0, I am just here on this imaginary axis. So my root locus like this, it satisfies the thing that I am symmetric about real axis, and all of them goes to infinity because there is no 0. Now how do they go to infinity? So first rule told me that it is symmetric. Rule number 2 told me that all will go to infinity. Okay, rule number 3 told me about, a point like this on root locus, this point, so real line on root locus, can I compute? See, if I am here, if I see on right hand side, I always have this 1 2 3 poles, there is no 0, so this number is odd, so therefore this point will be on root locus, this point will also be on root locus. So whole negative real axis is a part of root locus, right? And we know that this will go to infinity, so this path comes under root locus, so this whole real line will be of root locus. Okay, so angle here is computed by phi a 2k plus 1, so I am having q value equals to 3, so I kept it 3, I am just calculating, it should be 60, 180 and 300. Okay, so if I take from this point angle 60, if I draw, so this will be here like this will be 300 point. Okay, so these are the 3 angle point. Okay, so that is a good validation, and then these guys, they are how many asymptotes, so these guys will meet at line at some point, so these 3 will goes to infinity. Okay, so at infinity, not so now from where these asymptotes are generated, these angles, now I just by default I just make it like this. Is it like that? Okay, this is 60 degree, but where is that origin point? Where is that point from where this asymptote will originate it? For that calculation we will calculate the centroid. Okay, so centroid is a point of intersection. So it just look like a real part of poles. If you will see, real part of pole is 0 over here, this is itself 0, there is no 0, so no real part of zeros, so 0 minus 0 will be 0, so my centroid will be 0. So this graph will have something like this: one pole is here, one pole is here, one pole is here, and the asymptotes will start like this. This will be 60 degree, this is 300, this is 180 degree. Okay, so how the root locus will look like? Well, this guy will start moving little toward this direction. We will see what direction exactly it moves in little, in this direction or this direction. So, and I know it will mirror image it, then goes to infinity this way and this way. So I found out which direction these guys go a little later on, means how they will follow the path. But now I know this, its direction will be some here and it will be like infinity, and this is there. Okay, so similarly if I just draw it, so this is my root locus, so this is my centroid, these are my roots, one is here, one is here, another is at origin. If I just clear it once again, so this is one root, this is one root, this is one root, and this is the centroid point, and asymptote angles are given. This is 60, this is 180, this is 300. Okay, now how they will follow the path we will just see in coming rules. Okay, how we can identify what will be the path of this, how they will follow the, what will be their path for this green and red line. Okay, so again coming back to first example, so I start at 0 and minus a, and I know here that these guys move here and both will meet at minus a by 2, then goes to infinity at this point where they met, and then again go away, right? So they do not really stay together, just come here, come together, just say hello, and then they go to their respective paths. So now who decide y? Where is this y? Minus a by 2. Why not something here, or why not something here? Again, this is I know because I could just compute from computation of my quadratic equation. But what in general, right, in it just may not be able to again compute all the roots, and then it might be little time consuming. So this was good enough for understanding. Would decide this point and do that point and exactly, right? So that also is the thing. So I am just giving you characteristic equation. Suppose I am giving you a characteristics equation with polynomial s to the power 9, 16, s to the power 8, and so on, lots of things. So I should first know that does a breakaway point exist or not, right? So who tell me this breakaway point? Again, everything is from characteristic equation. So let us assume at this point what happened. So let that there are multiple roots, right? So the root here is 0, the root is minus a, or the poles, and then they come here, and then both the values have same value at a minus a by 2. And when this happen, my characteristic equation 1 plus k g h, well, I will have roots at s naught, okay, with some multiplying factor r times xs. Again, this xs do not contain this factor, and we will interested in situation where r is at least 2, right? Now I differentiate this guy, and this is on left hand side. So I have d by dt, this thing, this guy, and this is right hand side. I differentiated with respect to s. So differentiate first guy, and I will have r s naught r minus 1 xs. Then differentiate second guy, okay, with respect to s. So let's leave this here and then again come back. So in pole 0 form, I can write 1 plus kgs hs is equals to 1 plus kp. P is my new polynomial of numerator and polynomial in the denominator, and let's see what this guy has to do. Okay, so I can differentiate this guy, the earlier one. So when I am differentiating, I will just doing the same thing, right? So I am differentiating it and then equating to 0. Okay, so look at this guy. I know of course that s naught is a root, okay, is a root of the equation. So when I put the s naught, this term will go. If I put s equals to minus s naught, so this term will go, and I left with 0. So this d by ds is equals to 0. Okay, so I'm just keeping it 0. So where s naught comes with multiplying factor of r. So if the roots of equations are root of this differentiation, d by ds. Therefore we get k equals to minus q s by ps. Okay, so now to compute, I know qs and ps, and this might be because I may have, g and h might have numerator and denominator, and may have to do lot of other stuff, but then this is easier to compute. So this condition tell me that there is a breakaway point, right? So the breakaway points are the point at which multiple roots of characteristic equation occurs. The solution of this exact breakaway point can be computed, and the things here, it could be very trivially satisfying. So let's again see, compute for this example 1 plus, for that example if I see, it was k by s plus a is equals to 0. So if I write, it will be like 1, k will be minus s plus a, so it will be minus s to s plus a. So s we are equating to 0, we are differentiating with respect to s. So I will get this term, and then I am equating to 0. So s is equals to minus a by 2. Okay, so this is the breakaway point, and of course in this case it also turn out that this is 0, this is minus a, so this is minus a by 2 is my breakaway point, and it can happen in many cases. So this is like, okay, you can see why this is minus a by 2 using this explanation over here. So let's do a sketch of locus for this guy. I have again a pole at minus 2, minus 3, minus 4 and 0 at minus 1. Again the number of branches in root locus would be number of poles, that is 3, and these 3 branch, one will go to 0 minus 1 and other two disappear at infinity. again starting at k equals to 0, they will start at poles, okay, and then they goes to infinity. So let's first draw the basic condition. So that k equals to 0, my root locus will be at the poles, which is -2, -3, -4. And rule number 3, which part of the root on real line or real axis will be on root locus. So let's start here. -1, I am having my 0, okay. So let's start here. Well, there is nothing here, so this would not comes under root locus. If I am in between -1 and -2 here, so this part will be under root locus. Again, I am in right side of that, I am having 2, 1 pole, 1 0, so this is not there in root locus, this is under root locus, okay. So this is the part of root locus. Okay, now we will see the two roots that proceed to infinity to do all the asymptotic with angles. So phi is having two values, so it will be 90 and 270. So angle will be 90 and 270. So this is pole and this will terminate at 0. These two are pole, so where they will be, means what will be the angle? Angle will be 90 and 270. Okay, so we will just see them and we will calculate the centroid point. Again, real part of poles minus real part of zeros, number of poles minus number of zeros. So this is my centroid. And how can I calculate my breakaway point? I will keep dk by ds is equals to 0. So in my equation I will calculate this. I will calculate roots for this equations, and the root which lies on root locus will be my breakaway point. So I will just draw it once. So this is my -1, this is my pole. I will just repeat. So on this side nothing is there, so that is not root locus part. On this side of point I am having 1 0, so this is the part of root locus. I am here, then 2, 1 pole, 1 zeros are there, so this is not the part of root locus. This is the part of root locus because I am having total number of 3. On this point I am having 4, so this is not the root locus part. Okay, now centroid point is -4, so my centroid is here. So an angle of centroid asymptote is 90 and this is the angle is 270 degree. Okay, so these are 6 steps of construction.